Hey everyone, welcome back for the very last Chapter 3 video on our practice test. We're on to question 13, and we're going to answer the question about whether or not statistics is a cheerful mathematics. So I think you know the answer to that one. Let's take a look at the question. A certain psychologist counsels people who are getting divorced. Well, there you go. AP Stats, we get all the cheerful subjects. A random sample of 6 of her patients provided the following data, where X is the number of years of courtship and Y is a number of years of marriage. So if we take a look at that first data point, 3-9, that means that first person, they were only dating for 3 years and they got divorced after 9 years. Yay! Look how fun this is. How about that second couple? They were only dating for 0.5 years, for half a year, 6 months. And they got divorced after 6 years of being married. So, part A is to construct a scatter plot of these points. So, when you take out your TI calculator, you're going to go ahead and put in those X and Y coordinates into your stat. Actually, I should model getting into there. So we're going to push stat. Don't get scared by all the calculus. Stat, and then edit number 1. And you're going to enter in these coordinates here. I said coordinates. I should have just said data. Next, second, y equals brings up the stat plot menu. And we want to turn the first stat plot menu on. Change it to a scatter plot. Verify that that's where the x coordinates were, and that is where the x coordinates were. Verify that this is where the y coordinates are, and no, that's not where the list of y coordinates are. The y coordinates were in L2, second 2. To get the scatter plot, you'll push zoom, and then zoom stat, number 9. Great. Here is our scatter plot. And then you're going to transfer that over to the your paper. If you're doing this on an actual test, you'll probably have to copy all of this down by hand. But make sure you do a few things. First of all, make sure you do this by hand. Actually write it down and not copy and paste it like I did. And next, make sure that you scale and label each axis appropriately. So notice that I have them labeled. I have them scaled. The scaling makes sense. And yeah, other than the fact that I didn't draw this by hand, this is not that bad of a graph. So that's our part A. Part B, use a calculator to determine the least squares regression line. Write that equation and plot this line on the graph. Okay. Be sure to show what information you're showing. You're using to plot the graph. So let's grab our calculator again and let's figure out how to get ourselves the least squares regression line. And it is under math. It is not under math, my bad. It's under stat. Calculate least square regression line number 8. Is that the X list? Yes. Is that the Y list? Yes. Frequency list, always leave blank. Let's store the regression in y1, alpha, trace, y equals, calculate, and here is our linear regression, 5.36 for A, 2.68 for B. I'm going to go ahead and copy and paste that and put it into our work. So having that copied in here, and we're going to type in our regressional equation. Don't forget that we need predicted years of marriage equals 5.36 plus 2.68 multiplied by the years of courtship. So that is our regression equation in the style that I would like you to write it for my class. Now, letter C is to find the values of the slope and the regression in part B. We've already done that in this video, so I'm just going to quickly get to it. So the number of years of marriage when the number of years of courtship is 0 is about 5.36 years. That doesn't read the best, but I think given the circumstances, we're going to have to be okay with that. Slope is 2.68, so for every increase of 1 year of courtship, that was heavily edited to make it readable. The number of years of marriage increases by about 2.68 years. Yeah, and you could argue that the second years here is superfluous, also extra. But I'm not going to stress it too much. I hope you don't either. As much as we do interpretations, we do have to remember that this is a statistics class and not an English class. Letter D. What is the correlation between X and Y? So correlation is this R, which is 0.849. So correlation is equal to 0. Let's copy and paste that correlation interpretation from our sentence frames, and we'll go to work butchering it. So there is a 0.8, that's strong. So there is a strong, what direction is this? Positive? Well, the slope was positive, so the direction is positive as well. So there's a strong positive relationship between, and this is the years of courtship and years of marriage. There we go. One more time for readability. There is a strong positive relationship between the number of years of courtship and the number of years of marriage. Now remember, you probably don't want to say linear here, because correlation by itself never tells you whether a relationship is linear or not. For the linear, you have to look at the LSRL, or you have to look at the scatter plot, and you have to decide from the scatter plot. So let's move on to letter E. Letter E is, what is the value of r squared, and interpret this number. So it's another interpretation of r squared. We'll go through it quickly, but r squared is right here, 0.7125. So here is that interpretation again, and we're just going to fill in all our numbers. So this is about 72% of the variation in number of years of courtship. I mean number of years of marriage, of course. That's the response variable. Is accounted for by a LSRL with number of years of courtship. So as you're filling out these interpretations, make sure that you know which is the explanatory variable and which one is the response variable. And let's finish up this chapter 3 with letter F. I hope it's epic. Show how the residual of the first data point is calculated, then construct a residual plot on a second axis. Does that residual plot confirm or refute the choice of a linear regression, and explain? Whew, that's a lot of question. Let's, first of all, a little bit at a time. What are they saying in advisory class for, eat the elephant? Is that the one? I think it's eat the elephant. Show how the residual for the first data point is calculated. So that is wrap again. So let's get to letter F, and we're going to do our wrap. Residual is actual minus predicted. We have to have an actual. So the first data point, the actual number of years of marriage is 9. So there's that 9 right there. So that's actual. Predicted, we're going to have to run our regressional equation for 3 years. Okay, running through the regressional equation, we get a number of predicted years of marriage is 13.4, and that means our actual is 9. Our predicted is 13.4, giving us a residual of negative 4.4. Great, negative 4.4 is our residual. And next we're going to construct the residual plot. Let's take a look at that on the TI. Now remember, after you do a linear regression, your TI is going to automatically calculate the list of residuals. Mine happens to be in list 7. So to get yourself a residual plot, you're going to go to Stat Plot and change your scatter plot so that the Y list is residuals. You can call up residuals, the name residuals. Don't type it in. That's not going to work. You need to do second stat and then resid, wherever that is. Just like before, zoom stat, and here's our residuals. Let's take a quick picture of it. And we'll put it into our answers. Now don't forget, as you're putting this on your paper, that you will have to, in all likeliness, do this by hand. So use your calculator as a guide. Also, don't forget to to label your axes and to write down the data scales. And I forgot to put 0 here. 0 is kind of important. There's 0. So there's our residual plot, and let's see what other joys we have to do. Now that we have our residual plot, does a residual plot confirm or refute the choice of a linear regression? And do we see a pattern? That's the real question here. And I don't really see a pattern. Definitely I don't see a positive, negative, positive pattern. I don't see a negative, positive, negative pattern. And I don't even see the bugle pattern. So there is no pattern in the residuals. Maybe I should say obvious pattern in the residuals. So that means that there is no obvious pattern in the residuals, therefore the choice of a linear regression was a good choice for the data, or maybe we should say a good fit for the data. So that's it. That's a really long question, boys and girls, ladies and gentlemen, children of all ages. Hopefully that worked for you. And don't forget, you can always email me, hit me on Discord, whatever you need to do in order to get if you have any questions on this. And good luck on your Chapter 3 test. I'll see you for the next chapter.